Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning. In this lecture, we will focus on finding the volume of a solid of revolution bounded by a curve and the axis, bounded by two curves, bounded by a line and a curve. So basically, to find the volume from a function, okay, we need to draw the function, and then we will rotate this line over here about the x-axis or about the y-axis, and we will get an object where we can get the volume. In this first example, as you can see, if you rotate this line about the x-axis, we will get a cylinder. Okay, and the other one, if we rotate this line about the y-axis, we will get cone. Okay, and this one will give you a sphere. So to find the volume of solid of revolution, okay, we have two cases. The first one is where we revolve about the x-axis. As you can see from this line over here, the blue one, if we rotate the curve about the x-axis, okay, from A to B, to find the volume is pi integral of A to B y square dx. Okay, so we need to know what is the function over here and just plug in inside the function. Next, to find the volume that revolve about the y-axis, okay, we need to know what are the y coordinates, C and D, and then to find the volume, we will integrate from C until D, okay, and then plug in the function that has x as our subject and has square with respect to y. Now let's take a look at example number 1. We need to find the volume of solid of revolution by revolving the graph of this function about the x-axis only in the first quadrant. So first you need to take note. The question asks you to revolve about what axis. Okay, in this case, you want to revolve about the x-axis. So we write down the formula to revolve about the x-axis, and y is actually this. So we just plug in inside the formula, okay, and the limit will be from 0 until 2. Okay, so the limit will be on the x-axis because we want to integrate with respect to x. Okay, the process is just a normal integration, and this is the answer. The second one is to find the volume bounded by y equals to cos x and the x-axis from x equals to 0 to pi over 2 rotated about the x-axis. So here is our hint where we need to find the volume about the x-axis. Okay, so the formula, we must have pi. Okay, since it is about x, so we need to write down y squared inside the formula. Okay, kenapa y squared? Sebab nanti bila kita ganti, okay, y adalah ini. So cos kuasa 2 x dx. Okay, and the limit will follow the question 0 until pi over 2. The next step is where you just apply the rule of integration ataupun technique of integration yang ada lah. Okay, I'm not going to discuss it here. Okay, and this is the answer. Okay, I'm going to emphasize on how to write down the formula of volume in this lecture. Okay, now example number 3 over here, we have example number 3. We need to find the volume of solid obtained by rotating the region bounded by y equals to x cubed, y equals to 8, x equals to 0, and most importantly, you must take note that we want to find the volume rotated around y-axis. So first you need to write down the formula y-axis. So here must be x squared. Okay, so now based on the sketching, okay, you will sketch the graph. You will see that the region bounded is over here. Okay, so we want x as subject, so we need to write down x equal to y power 1 over 3. Okay, so now we can substitute into the formula, okay, from 0 until 8. Okay, so sini kalau x kosong, y pun kosong kan. So sini y equals to 8 lah. Okay, and then you just need to integrate using the rule of integration. Okay, so here are more information where we have two curves and we want to find the volume rotated about the x-axis of this shaded region R. Okay, so the formula will be V equals to pi, okay, from A until B, okay, and then y squared inside. But since we have two different curves, we need to square separately y1 and y2. Okay, for example, in this case, if you can see, we have a sketching over here. Okay, find the intersection point and we will get -1 and 2. Okay, -1 and 2. So the volume will be from -1 until 2. Okay, so we take the upper curve over here, okay, which is x plus 2, and then we square, minus the lower curve, which is x square, and then square. So remember to square separately. Okay, and the limit will be from -1 until 2. Okay, since we are dealing with respect to x, so kita kena tengok limit dia dekat x-axis lah. Okay, and then we just need to integrate as usual. Okay, how about if you want to revolve about the y-axis, this shaded region. Okay, so kita akan ambil separately lah nilai x dia. Okay, for example, in this case, kita akan ambil yang sebelah kanan sekali. Kita akan start dengan yang kanan. Okay, so yang kanan ini, function dia adalah y equals to 2x minus 4. So we must make x as our subject. So we get y plus 4 over 2. Okay, and then we substitute into the formula. Yang paling kanan sekali adalah ni. So kita kuasa 2 kan. Dan kita akan tolak dengan yang lebih kiri lah. Okay. And then untuk jawab ni just guna rule yang biasa lah. Okay. So I want to show you one more example before exercise. Okay. So in this example, okay, dia adalah arahan dia kan. Dia cakap lah suruh integrate, find the volume about the x-axis and then dah siap lukis. Okay, madam cuma nak emphasize di sini, kalau perhatikan daripada rajah ni kita ada, kalau about x-axis, kita tengok ada atas dan bawah kan. Okay, atas dan bawah dia punya shaded region. So to find the volume, awak tak perlu risau untuk letak absolute sign. Because kalau awak tengok formula dia sendiri dah ada kuasa 2. So dia tak akan dapat jawapan yang negatif lah. Okay, so hanya untuk area saja di bahagian ini awak perlu letakkan absolute sign. Okay, tapi jika nak kira volume, awak tak perlu letak absolute sign. You can straight away calculate from -2 until 2. Nampak? Dia punya limit pun memang straight away from -2 until 2. Okay, so kita boleh integrate terus lah. Okay, so harap awak take note lah. Sama lah juga dengan about y-axis. So dia tak perlu kira kanan kiri, tak perlu tak absolute dah untuk kira volume. Okay, because the formula itself has square. Okay, and now please attempt this exercise for this lecture today and send to me as soon as possible. Okay, because I want to review how your understanding on finding the volume of a function. Okay, so make sure you sketch the graph, shade the bounded region and check whether your answer is correct or not. Okay, so thank you. Bye-bye.